One of the things I'd like to do this week is to spend some time highlighting some features of the program that you might not have noticed when you were first working with it. One of them is this interactive guide over here. And since this is the kind of a program that you're probably going to be using from time to time and not on a daily basis, you might find this helpful when you come back to the program in showing you how to use some of the features. The way that this works is basically you can just click the next button and the program will walk you through all the parts of the program. So for example, over here, if I come to the part that says, let's pick the one for the ICC or span of means, and I click next, and it says to compute power, we need to know how the control group means vary across level 2s. If I've gone back and named these things before, as I would suggest you always do, so let me just come back over here and give these the names. We'll call the schools at the top level and students at the bottom level. Then this is going to say to compute power we need to know how the control group means vary across schools. This span can be reported directly, or it can be reported as an interclass correlation, an ICC. And then it goes ahead to explain what all of these things are. Before entering the ICC or the span of means, set the mean for the control group. This has no effect on power, but yields a more informative display. To set the mean, select the control group mean on the ICC menu, which you could do over here, or click the button below, and we can do that. And let's see, that didn't seem to be working, so let's click this one. Okay, and then we over here give it the overall mean, which is 500, and click OK. The program offers two options for entering information about the dispersion of a control group means. You can enter the ICC or you can enter the span of means, and so on. And it will walk you through this and explain how the ICC is defined, how to read the display, and so on. Something else that you can do with this, well, you can actually walk through every step just by clicking next, and that's actually probably a good way to go because it takes you through these in a logical sequence. If you wanted to jump to any part of this, for example, let's say you want to come back here and know about levels, you just click on the top and it takes you right back to there, the study design. Or you can click over here, number of covariates, and it takes you to that part, which is the number of covariates and the R squared. So this is a good way of finding your way around the program. There's an entirely separate help system. This first one, by the way, the interactive guide, you control over here. You can always turn it off by clicking there, and you can turn it back on by clicking interactive guide. There's a separate help system which you can turn on by clicking show details. When you click that, and then you come in here and click on any particular value, for example, over here I've just clicked on the ICC value of 0.0 for schools. The program gives me a lot of information about that particular value. So it says over here ICC or span of means. First it has the general information about that. If I click on definition, it gives me the definition of it. If I click on the range, it tells me what the possible range is. If I click on impact, it tells me what the impact on power will be. If I click on current, it tells me what the current value is. The ICC for schools is 0.0. If it was something else, for example, if I set that at 0.05, it would tell me that the ICC for schools is 0.05, and it tells me how to modify that value. If I come over here and click on the word random, it tells me that I'm looking at the sampling model for schools. It explains again what this means in general, what the definition of a fixed or a random effect model is, what the possible values are, what is the impact on power, and so on. So the basic idea of this details is that you're not clicking on so much on the top of one of these, but you're actually clicking on a specific value, and you're getting information for that specific value. And in many cases, you're going to find this helpful as well. This again can be turned on or off over here. You can actually have both of them going at the same time if you want to. They work independently of each other. So that's something you can keep in mind. What else do we have over here? The license manager is self-explanatory. There's this thing over here, show menus for the optimal design program. If any of you have been working with the OD program, which some of you will be aware of, the two programs, our program and OD, have an overlapping set of designs that we deal with. We cover some designs that they don't cover. They cover some designs that we don't cover. But there are 8 designs that we have in common. And when you're first making the transition from OD to CRT-Power, you might have trouble finding the design in CRT that matches whatever you were using in optimal design. So what we've done over here is we've copied the optimal design menu for those study designs that we have in common. So for example, in optimal design, if you were working with continuous outcomes, there would be 5 designs you'd be able to choose from. And let's say you pick person randomized, multi-site, or blocked trials. You click on that and the program over here comes up with the corresponding design, which is a 2-level study, blocked at the top, randomized at the 2nd level. Or if you picked cluster randomized trial with person level outcomes, and then you went to the submenu which said cluster randomized trials, and then to the submenu which said treatment level 2, if you click that, it gives you the corresponding version of that over here. Or if you click this one, it gives you the corresponding version over here. So this is simply a way for people that have been working with optimal design to make the transition to CRT-Power as easily as possible. Of course, if you've never used optimal design, this is probably not going to be something that you need to bother about. Okay, so that's a couple of options on the help menu that I wanted you at least to be aware of, and you can always come back and use them when appropriate. I'd like to highlight one more feature of the program that I haven't looked at so far, which is how to compute the minimum detectable effect size. This is something that people often want to know. Let's say that we're setting up a study and we decide that, we can include 10 districts, and within each district we can include 5 schools, and within each school we can include 4 classes, and within each class we can include 20 students. Based on that, what is the smallest effect size that I can find with power, let's say with power of 90%? What you do is first you click over here and pick the power that you want. Then you click Find MDES. And the program immediately computes that, and you can paste it and paste that and close the panel. And the program is telling you in this case that with this particular study design, you're going to have 90%, you would have 90% power to detect an effect size of 0.3. Let's say for the sake of argument, you come back and say, well, I can have 10 schools per district. What would be my minimum detectable effect size? Again, you click that, and the program says it would be an effect size of 0.262. You can paste that and close it, and we have an effect size here of 0.262. So this is simply a very quick way of finding the smallest effect size that you'll be able to detect. Obviously, you could do that also by simply clicking on this until this number matches 90%. And this is simply a one-step way of doing it. Another feature of the program that I'd like to show you is I've been assuming all along that we want to have an equal number of units in the treated group and the control group, but that's not necessarily the case. Let's say, for the sake of argument, that we wanted to have more students in the treated group than the control group. You can right-click over here. By default, we're saying to link the number of districts for the two groups, but we can set the number for each one separately. And when we click that, then we get a separate box for the left one and the right one, and we can manipulate each one of those independently of the other. Similarly, over here, for costs, we've always assumed that they're linked, but you can set them separately. For example, let's say that in the treated group, where we're going to be giving out these kids are going to be getting vouchers that they can use to get training for the SAT. That, I guess, this probably would take place at the student level. But for every student that's getting the voucher, we might expect the cost to be $1,000, because that's what the voucher service is charging us. Whereas for students that aren't getting the voucher, the cost is only going to be $200, because all we need to do is follow them, but we don't need to contribute a lot of money to them. So you do have the option of having a different price for each group, and you can do that separately for you can set that for districts, schools, classes, or students. In other words, you can this and this are independent, and whether these are linked or not can be set independently for each of the levels. The only caveat to this, which this is actually pretty neat, the caveat is that when you go to use the optimal design wizard, if I remember correctly, you're allowed to have different prices for this and this, but I'm sorry, I have to set these values to more than 0. So we were using, I think, let's say 4,000 for each district and 2,000 for each school, and let's say 500 for each, 800 for each class. I believe that when you click compute and paste it, what the program is going to do is it's going to honor these different costs over here, but it's going to come up with a number of units that's the same for both of them. And this will sort of give you a starting point. You can then go back and manipulate these so that you can say, okay, well, I want to have more in one group than the other. You can change that, but this is a good starting point for figuring out what your optimal design is going to be.